Hello, so in this video today, we're going to answer question 5 from the 2022 Mechanics Paper 3 exam from Edexcel. So this was last year's exam, so I'm recording this video right now in 2023 in preparation for the Paper 3 exam coming up next week. But yeah, this was 2022 Paper 3, the Mechanics section for the Edexcel syllabus. And we're going to answer the final questions, this projectiles question here. So the last question on the exam, so probably the most difficult one. So let's have a go at this question here then. So we've got a golf ball at rest at point A, is at rest at point A on a horizontal ground. So we've got this horizontal ground here, and the ball is hit, and it's going to initially move at an angle of alpha. So we've got this angle alpha there. The ball first hits the ground at point B, and we got a distance like this horizontal distance there of 120 meters. So from A to B horizontally, it's 120. So I've shown in the diagram there. Yeah, so it just goes, starts from the bottom, goes up, goes down. So just a straightforward projectile, this one. The motion of the ball is modeled as a particle, and it's moving freely under gravity, whose initial speed is capital U meters per second. So the first part of the question is to show that U squared times by sine alpha cos alpha is 588. Okay, so with these projectile questions, usually, I mean, 90% of the time, 95% of the time, you always start by using the Suvat equation, S equals UT plus half AT squared. So generally, the equation we always use to start off with these Suvat equations is this Suvat equation here. And that's because in questions like these, especially like part A of a projectiles question, we're not really worried about like the final speed of the V in the Suvat letters. We're not really worried about the V with these questions generally. I mean, unless the question were to ask you about, you know, the final speed of the projectile or the maximum height of a projectile, in which case when you reach a maximum height of a projectile, your final speed is 0 vertically. So if you throw a ball up in the air, your vertical final speed at the maximum height would be 0. So unless we're dealing with questions talking about a final destination, we're not going to be worried about any Suvat equations with V with these projectile questions. Again, unless we're given we're asked a question about a final destination, it's like a maximum height, the final speed. You know, we're not really interested in using the equation involving V. So we want to use the equation that doesn't involve V. So it's this S equals UT plus half AT squared equation. So remember projectiles, we want to do Suvat in 2 directions, horizontally and vertically. So that's what we're going to do at part A. So I mean, part A is not telling us to do that, but that's always going to be our starting point. When we get a show that question, we're always going to start off by using Suvat in both directions. So let's do Suvat firstly in the horizontal direction. So Suvat in the horizontal direction. So before we actually do our Suvat, let's just think about our initial speed. So we've got, if I draw like a triangle like this, we've got an initial speed of capital U. We've got an initial angle of elevation of alpha. So you can kind of think about this like a right angle triangle. So right angle triangle there. Now we've got so that means we've got an initial horizontal speed of U cos alpha. So remember, cos is adjacent over hypotenuse. U is the hypotenuse. So that means the adjacent must be U cos alpha. And so therefore, you've probably guessed it, our initial vertical speed is going to be U sine alpha. So that's going to be helpful with this question here. So if we think about our Suvat letters horizontally, so again, we want to use the equation S equals UT plus half AT squared, because again, we're not worried about V, the final speed in this question. We just want to think about these other letters. So our S, so what's our S going to be horizontally? Well, the question tells us it's 120, isn't it? So to go from A to B, our horizontal displacement, our horizontal distance is 120. So horizontally, we've got a distance of 120. Now, how about U, our initial speed? So we just looked at this in the triangle up here. So initially, our horizontal speed is U cos alpha. Let's write this here. So capital U cos alpha. Now, what about our acceleration? So horizontally with the Suvat equations, remember, horizontally, there is no acceleration. It's just a constant speed horizontally, and it's always going to be the case with these questions. And then the time taken, I mean, we're not told anything about the time taken, are we? Let me just read the question again. No, we don't know that. So I'm just going to call this capital T. So the time I'm just going to call capital T. So now we can use our S equals UT plus half AT squared equation. So S equals UT plus half AT squared. Now the acceleration is actually just 0. So actually we don't need to worry about this second term here because that's just going to be 0, because 0 times anything 0. So we're just going to get S equals U times T to speed. So sorry, distance equals speed times time. So distance is 120, and that's going to be equal to U cos alpha, and then times by this time. So actually what we can say is we can say that the time is equal to, so the time of flight, so the time to get from A to B is 120 over U cos alpha. So that's probably going to be useful. Well, I mean, I'm pretty much sure it will be helpful to get the final answer that we need, this result here. So we've done SUVAT horizontally. We can't really do much with that. Now let's do SUVAT vertically. So let's do the same calculation, but in the vertical component, in the vertical direction. Okay, so so our distance vertically, so our displacement vertically, I should say. So let's think about it. So vertically, we go up, and then we go back down again, don't we? So we start there, we go up, and then we go back down. So our vertical displacement 0. So vertically, if we just think about the y-axis, I mean, if we draw like some axes here, our y, so that's our y-axis, that's our x-axis. So our y-axis, our y-coordinate, is still the same as before, isn't it? So vertically in the y direction, there's no displacement. So basically, S is going to be 0. So our displacement is 0 in the vertical direction. Now, how about our initial speed? So looking back at our triangle, initial speed, U sine alpha in the vertical direction. So capital U sine alpha. And then how about acceleration? So acceleration, now we're going upwards. So we're going in the vertical direction. So our acceleration is negative G. So why is it negative? Let's just remind ourselves why it's a negative gravitational acceleration. That's because if our initial speed, so remember SUVAT letters, we're dealing with, you know, vectors here. So velocity, acceleration, displacement, these are all vectors. So remember, if we've got a positive velocity initially, so U sine alpha is a positive value, our acceleration is going against the motion, isn't it? So our acceleration is trying to pull us downwards. So acceleration is going in the opposite direction as our initial speed. If we say that our initial speed is positive, then that means the acceleration is going to be negative because our acceleration is due to gravity, which is going against the motion. So it's a negative vector, so negative G. And then our time is, well, it's the time before, the same T, isn't it? It's the same capital T as before, because that's the time of flight. So the time to go from, to go from there to there, it's the same time as before, isn't it? So it's the same, it's the time of the journey. So we've got that there. And we know from the previous calculation that we did, the SUVAT horizontal calculation, we know that T is this, so 120 over U cos alpha. So now we can use this and again use the equation S equals UT plus half AT squared. We're going to use that equation again, and we're just going to plug in our numbers. So S is 0, U is this U sine alpha, T is this thing that we got here, this 120 over U cos alpha, and then we've got plus a half times A. Now A is negative, it's negative G, so I'm actually going to write it like this, so negative a half G, and then times by the T squared, so this fraction here, this 120 over U cos alpha all squared. Okay, so that's going to be our equation. In fact, what I'm going to do is I'm just going to factorize out this. Well, first and foremost, I'm actually just going to divide, because we've got a U there divided by U here. So U over U, that just cancels out. I'm just going to write it like that instead. So we've got 0 is equal to 120 sine alpha over cos alpha, and then minus, yeah, I'm just gonna keep it like this again. So we've got half G and then 120 over actually what am I gonna do? Forget this. Let me just rub this out here. I am just going to expand out the brackets here. Let's just expand out the brackets here. So we've got again, yeah, G over 2, so half G, and then 120 squared. Sorry, let me get my calculator over here. 120 squared, can't do that in my head. 120 squared would be 14,400. Okay, so we've got 14,400 there over, so u cos alpha all squared, that's going to be a u squared cos squared alpha. Okay, so we get that. So then now then, well, we've got 120 sine alpha over cos. I'm just going to write that as tan, just to simplify a little bit. So we've got 120. Actually, no, I'm not going to do that. No, I'm not going to do that. Just because looking at the question that we've got, just by looking at the we just scroll up to the question again. So we want to try and show that u squared sine alpha cos alpha is 588. So I'm just going to keep the sines and the coses involved rather than like convert the tan, just because it's going to get us close to the answer that we really, really want. I'm actually going to multiply everything in this equation by this denominator here. So this 2 u squared cos squared. I'm going to multiply everything by that. So multiply everything, so times everything, sorry, everything. I'm going to write this out and try and write that again. So we're going to times everything by 2 u squared cos squared alpha. And the reason for that is because we're then going to get rid of this denominator in our second term, so this 2 u squared cos squared on the bottom of this second fraction. So that's what we're going to do. And if we do that, so 0 times by 2 u squared cos squared alpha, I mean, that's still going to be 0. Anything times 0 is just 0. And then we're going to get 120 sine alpha, and then times by 2 u squared cos squared alpha, all divided by cos alpha. And then take away, so we're going to times everything. So we're going to times this second fraction, g times 14,400 over 2 u squared cos squared alpha. We're going to times it by 2 u squared cos squared alpha. So the 2 u squared cos squared alpha cancels out. And so we're just going to be left with 14,400 g. So hopefully that all makes sense how I did that. So multiply everything, all three terms by this 2 u squared cos squared, and we get that. So we're actually just going to, I'm just going to simplify this a little bit further. So we get 0, and then 120 times by 2, well, that's going to be 240. So 240 sine alpha. I'm actually, do you know what, I'm going to write the u squared at the start just to make it look a little bit neater. So 240 u, sorry, capital U, let me write a capital U instead. 240 u squared sine alpha cos squared alpha, all divided by cos alpha, and then take away this 14,400 g. Now, what you'll probably notice now is that you've got a cos squared on top of this first fraction and a cos on the bottom. We can cancel out one of the coses there, so we cancel out the cos there. So that means we're left with 0 equals 240 u squared sine alpha cos alpha, and then take away this 14,400 g. So we're getting closer and closer to our answer. So I mean, if we just go back to the question, it doesn't say anything about what value of g we got to use. So we're going to use g equals 9.8. That's the value we're going to use. So if we just take g equals 9.8, then we get 0 equals 240 u squared sine alpha cos alpha, and then take away, so 14400 times by 9.8. So on my calculator I get this, so 141,120. So I'm just going to add that to both sides to get 141,120 equals 240 u squared sine alpha cos alpha. If we just divide, so I mean, again, if we look at what we want to get u squared sine alpha cos alpha is subject to the formula. So we're going to divide both sides by 240. So 141,120 divided by 240 is equal to u squared sine alpha cos alpha. And hopefully, when we put this in the calculator, hopefully we get the right number. So 141,120 divided by 24. Yes, we get it. So we get 588. So 588 equals u squared sine alpha cos alpha. And so we've answered part A of the question there. Okay, so that's the first part of the question done. So we've done that. You see that in both directions. and just do some rearranging of equations, we get the result. Now, the ball reaches a maximum height of 10 meters above the ground. So we've got to show that u squared is 1,960. So now we're talking about a maximum height above the ground, so like this point there. I'll just call it this point there, capital M for maximum. So that's our maximum height there. So, I mean, I'm just going to draw a new diagram to kind of visualize what's happening here. So this is part B of the question. So we've got our golf ball there. It was a golf ball, wasn't it? Let me just check. Yeah, we're talking about golf balls here. Yep. So we're starting down there, and then we get to our maximum height here. So maximum height, this is a vertical kind of variable. We're talking about vertical motion now if we're talking about like a maximum height. So we're told that this displacement vertically, again, we're told that was 10, wasn't it? Yeah, so it's going to be 10 meters above the ground. So we've got like a vertical displacement there at 10. Now we know that our vertical initial speed, so like our initial speed vertically. So we're thinking about vertical motion here. So again, I'm just going to put a title, vertical suvat, or a subtitle. So vertical suvat. So we've got displacement 10. We've got initial speed vertically of u sine alpha, so what we had before. And we've got an acceleration negative g. And we've got, yes, we got a final speed at this point there. So a v value of 0. So remember, if you throw a ball straight upwards in the air with some initial speed, once it gets to the top, it momentarily stops, doesn't it? So throw a ball in the air, gets to the top, it momentarily stops. So the final velocity at the top vertically is 0 because it's momentarily stopped at the maximum height there. So now what we're going to do is we're going to use suvat with these letters here. So we've got S is 10, V 0, U, which was our initial speed vertically, and our acceleration there. So we're going to use the equation. So we haven't got T involved here. So we're going to use the equation that doesn't involve T, and that's this equation here. So it's the V squared equals U squared plus 2AS equation, because there's no T involved in this equation here. So pick the equation with T missing. It's this one. So V is 0, so we get 0 squared, which is just 0. Now U is this U sine alpha, so we get U sine alpha. We're going to square all of that. And then we've got 2AS, so plus 2 times negative g. So we're going to get a negative 2g, and then times by your displacement of 10. Okay, so we get 0 equals, so U sine all squared, that's going to be U squared sine squared alpha, and then take away 20g. So therefore, we know that U squared sine squared alpha is 20g. So we've got that there. So then what we now know, I mean, if we just square root both sides of this, actually, should we square root both sides of the equation? No, I think I'll just leave it like that. Yeah, I think I'll leave it like that for now. Yeah, so we want to, so the objective of this, remember what we're trying to do in this question. We want to find U squared. We want to show that U squared is 1960. So I'm gonna leave it like this for now. So we've got, yeah, U squared. Actually, no, do you know what I'm going to do? I'm going to make U squared the subject of the formula, actually, because we want to get U squared. We want to get a formula for U squared. So actually, I think it's a smart idea if we actually divide both sides by sine squared. So we're going to get U squared is equal to 20g over sine squared alpha. Okay, so we now know that. So remember from part A of the question, I mean, we did part A of the question for a reason. There's a reason why we did this, is that we got U squared sine alpha cos alpha equals 588. So we need to use that piece of information. We've not done that part A for nothing. So let's use that piece of information. So we got in part A, we know, I'm just going to write here, but from part A, so from A, we know that U squared sine alpha cos alpha is 588. So I know also that U squared is equal to, if we divide both sides by sine alpha cos alpha, again, I'm just going to write this a little bit neater, divide both sides by sine alpha cos alpha, we get that U squared is 588 over sine alpha cos alpha. Okay, great. So now then we've got two equations for U squared. So we've got this one here and we've got this one here. So I think what I'm going to do is just set these two fractions. So that one there equal to that one there, because they're both the same u squared. So we know that 5, 8, sorry, let me get rid of this and do this again. So we've got 5, 8, 8. So 5, 8, 8 over sine alpha cos alpha is equal to 20g divided by sine squared alpha. If we times both sides by sine squared, what do we get? So if we times both sides of the equation there by sine squared, so we're going to get sine squared alpha 588 over sine alpha cos alpha equals 20g. And as you probably noticed, one of the signs will just cancel out there. So we've got that. So we've got sine alpha. So therefore, sine alpha over cos alpha times by 588 is equal to 20g. Just 20g. I don't know why I put the fraction there. Okay, so we got that. So we know that sine over cos is actually just tan, isn't it? So therefore, we can say that tan alpha times by 588 is equal to 20g. And so therefore, we know that tan alpha is equal to 20g over 588. And in fact, I'm just going to leave it in numerical form. So g is 9.8. So 20 times 9.8, what does that give us? That will give us 196. We get 196 there over 588. I'm just going to try and simplify that fraction in my calculator. So 196 divided by 588, that is 1/3. Okay, right, so we get a nice number, right? So tan alpha is equal to 1/3. Okay, so that's going to help us out. So remember, we want to find u squared. Now, if we think about it, we know that, well, we can either pick this formula here or this formula here. It doesn't matter which one we pick. But we know that if tan alpha is 1/3, let's just try and draw like a diagram for this. So we've got angle there of alpha. Now, remember, tan is opposite over adjacent. So opposite over adjacent, that's the definition of tan. So we can just draw like an arbitrary triangle, arbitrary right angle triangle. Our opposite we'll call 1, our adjacent we'll call 3. So what would this hypotenuse be? So using Pythagoras, it's going to be 1 squared plus 3 squared, square root all that. So we get square root 10. So we know that therefore, just by using SOHCAHTOA, sine alpha, opposite over hypotenuse, that's going to be 1 over root 10. And we know that cos alpha is going to be 3 over root 10, my bad, sorry. Adjacent over hypotenuse is 3 over root 10. So we now know the cos and the sine values. So now we can go to either this formula number 1, or this formula number 2 to work out u squared. Doesn't matter which one you pick. I mean, let's just go with the second one. So let's go with equation number 2. So therefore, u squared equals 588 over, this should be sine alpha cos alpha. So sine alpha cos alpha. And that's going to be 588 over, this should be an 8 there, that's an 8, over 1 over root 10 times by 3 over root 10. Just try and simplify this fraction. We get 588 over 3 over, so root 10 times root, so times the fractions, 1 times 3 gives us 3. Root 10 times root 10 is 10, so we get that there. And then, using fractions, we get 588 divided by, so remember, division by fractions, keep, change, flip, so times by 10 over 3. Now, when we put this in our calculator, hopefully we get the right answer. 588 times by 10, divide by 3. Yes, we do. We get 1,000. Sorry, let's just rub this out. 1,960, which is, if we go back to the question, that is what we needed to get this there. So we've done part B. Great. So now let's go on to the very last 2 questions. So in a refinement to the model, the effect of air resistance is included. Right, so we've got air resistance now, which means we've got a force going against our motion now. So the motion of the ball from A to B is now modeled as a particle whose initial speed is capital V. Okay, so now the new speed after the air resistance has been added is capital V. So we've got a state which is greater, u or v, giving a reason for our answer. So, okay, so we've got this golf ball. In fact, I'm going to get rid of all this mess here. Let's just rub this out here. I'm going to rub out the equation there as well. So we got this golf ball going from A to B. So initially, the initial speed before was going to be just, it was just U, wasn't it? So this capital U. Now we've got air resistance. We've got a model. So we want to go from A to B. So the question's telling us that we start at A and it's going to hit the ground at B. So it's got to travel 120 meters. So initially there was no air resistance. So we didn't have to go against air resistance initially. So we just had this speed U. We didn't have to work against the air resistance. We just traveled from A to B. But now with this V, we've got to fight against air resistance, but we still got to land 120 meters. I mean, we still got to go from A to B. So we still got to travel 120 meters. So which is going to be greater? Well, V is going to be greater. So I'm going to try and fit it in. Should I go down to the end of here? Oh, I've not got much room. I'm just going to fit it in here. So I'm just going to call this part C here. So V is greater than U. Why is the reason for that? Well, that's because we have air resistance now. So in order to travel the same distance horizontally as before, we've got to have a bigger initial speed because we're fighting against air resistance. So V is greater than U because air resistance, means this is going to be very difficult to write, very small with my awful handwriting, but let's try our best. So because air resistance is acting against us, against the golf ball, I should really say. So it's acting against the golf ball. So we need a greater speed than before. So we need a greater speed than before in order to travel the same distance. So we need a greater speed than before in order to travel the same distance, because now we've got air resistance pushing against us. So we've got to hit the ball faster than before, because otherwise, if we don't hit it faster, we're going to land like back here because air resistance is pushing against us. So we've got to hit the ball harder and faster because the air resistance will push us backwards. So we've got to hit it faster than before to fight against the air resistance. So some kind of sentence like that would be fine with this question here. Okay, so now let's go to the very last question on this paper. So state one further refinement to the model that would make it more realistic. So we've got air resistance now, so we can't use that reason. What else could we say? I mean, with these projectile questions, we always assume that they're particles. So I guess a good reason or a good refinement could be assume that the ball is not a particle, assume that the ball is spherical. So you could say that. So let's write down some assumptions. Well, let's try to write down some assumptions down here. Try and put a box around this just to get some space. So you could say assume ball is not a particle, so spherical, for example, so not a particle, e.g. Sphere. So I mean, in these mechanics questions, we always assume that the things traveling are just dots, which is obviously is not realistic. So we can assume that we've actually got a ball that has a center of mass, has a particular shape, and that would affect the calculations. We could say assume that there is, so take into account spin, because obviously with a ball, if you hit a ball, there's going to be rotation. So we could take into account spin. So take into account spin / rotation of the ball. So take into account rotation / spin. So that's a good one with these projectile questions that you can always use. What else could we say? I mean, I guess you could say assume there's not a constant acceleration. So with these questions here, we assume constant acceleration. So you could say that there. So you could say consider a non-constant acceleration. So consider a non, or really I should say variable, that's really the correct word to use, isn't it? So consider a variable acceleration. So again, when we use constant acceleration, that means we use that, but we could assume that there's a variable acceleration. Maybe it's more realistic to assume that. So we could consider a variable acceleration. What else could we say? I mean, we could say take into account other forces. So take into account, for example, wind. So we could take into account wind, slash other 3D forces. So in reality, when you hit a golf ball, you're not traveling in 2D, you're traveling in 3 dimensions, aren't you? So, I mean, with these projectile questions, I mean, again, if you think about it, we always assume we're going in 2D, like on an XY axis like that. In reality, you're going in 3D, aren't you? So taking into account things like wind and other 3D forces is a good one you can say as well. So 3D forces. So yeah, there's some reasons that you could use. Just one of them would be fine with this question here. Okay, great. Yeah, so that was the final question from the paper 3 2022 mechanics paper from Edexcel, of course. Just a projectiles one. Any questions, do leave them in the comment section. And if you do need any help with your exams to prepare, please send an email, doctordifferentiation@gmail.com. I'll just write my email up here. If you want me to answer specific questions for you, remember I charge about 1 mark per question on my email. Or if you just have like a brief question, you just put it in the comment section to this video. So doctor differentiation. As in, yeah, doctor as in doctor, and differentiation is in like differentiation in maths at gmail.com. And if you are maybe like a year 12 student or like, you know, someone maybe in year 11 looking for some A-level maths tutoring, again, send an email. My standard price is £35 for a session, so 50 to an hour, 15 minutes to an hour session between that kind of time. And yeah, do send an email and we can arrange sessions if you need sessions. So £35 is my price a session. So thanks a lot for watching and good luck with the rest of your A-level maths revision.